Good afternoon. So I would like to start today to set the scene for my talk by asking you all a couple of questions. Could you please put your hand up if so far this year you have had a cold or the flu, something that feels like that so far this year? Please put your hand up. I'm not going to pick on anyone, I promise. So from what you can see, that's going to be almost everybody here, which is what we expect. The common cold is common. And most adults, we expect that you may get a cold or the flu about once every 3 months or so. And for children, you may not be surprised to hear it's about 6-7 times per year. Okay, so next question. How many of you have had COVID so far this year, or think you may have had COVID? Could you put your hand up, please, as well? Okay, so from what I can see, I mean, obviously not everyone, but it looks like maybe about 1 in 10, 1 in 20 or so may have had COVID. And if we knew the true number of infections, it's almost certainly going to be much higher, because a lot of infections, the symptoms are quite mild or even don't cause any symptoms at all. And even when they do cause symptoms, it's not that often that we actually go and get a test to find out what the virus is. Okay, so now one final question. How many of you will consider, for a research study, getting paid to get an infection? Will you put your hands up? If you would consider this, would you consider getting COVID, getting paid to get COVID for a study? Okay, thank you. Maybe a few people here who I think are interested. Maybe some people feel a little bit surprised by this idea. And this is what I want to talk about today, about why I've been asking people to volunteer to get sick for science. But let me just give a bit of background, a little bit about me first. My name is Barney. I'm an infectious disease doctor and researcher at the National Center for Infectious Diseases, NCID. Since the beginning of the pandemic in January 2020, I've been on the wards treating my patients who have COVID. And I've been in the lab, or more accurately my office, trying to work out ways that we can prevent it. And last year, I started on a new approach, new to me and new to Singapore. And for the first time a year ago, I found myself putting on my protective equipment, the gloves, gowns, goggles, and mask, and putting a virus into someone's nose with the aim of actually causing them to get an infection, in this case, to get COVID. And that brave, very first participant who's shown up here, a recent NTU graduate who's also graduated from our study as well. Planning for this human infection study actually started some time ago. We started the inoculations last year. Planning took a lot longer than that. And when first talking about this study with other doctors and scientists, their reaction was, I think, perhaps similar to how you may have reacted here as well. Many were immediately enthusiastic about the fantastic science we could do with this. Some even told me we should have been doing these studies a long time ago. But for some, there was some surprise, and they asked me, are you even allowed to do this? And I was prepared for these sorts of reactions, because on the face of it, a doctor intentionally giving their patients an infection sounds like such an unethical thing to do. And if we look back over human history, and particularly events over the Second World War, it's understandable why. But in the aftermath of the Second World War, there was an international coming together and a fundamental realignment of medical ethics. And the Declaration of Helsinki was one of these agreed upon documents that came out of this. And it's now been accepted around the world. The declaration continues to evolve and be updated, and it was actually exactly 50 years ago, in October 1975 in Tokyo, that a major amendment advocated for the review of all medical studies by an independent ethics committee, an institutional review board, or IRB. And this review is designed to protect the rights and the well-being of all people who take part in medical research. And it really has become a fundamental requirement for research ever since. And so it is in this context of advances in medicine and science, and also advances in ethics and the law, that now an increasing number of researchers around the world have concluded that in the right situation, studies which involve the deliberate infection of volunteers offers unique advantages when conducting infectious diseases research. Why is that, and how will these studies and the volunteers who put themselves forward for it, some who I hope may be sitting here in the auditorium today, how can you help to prevent the next pandemic? Let me give a little bit of context to all this, first of all. So, childhood vaccines developed over the past 50 years have saved millions of lives. Yet, for many infectious diseases, we still don't have vaccines or treatments, or the ones that we do have are not as good as we would like them to be. Take COVID as an example. I would guess that almost everyone in the room here has been vaccinated 2, 3, 4, maybe even more times than that. And yet, I also expect that almost everybody in here, whether you know it or not, have had COVID once, twice, 3 times, maybe even more than that as well. The vaccines, when they first came out, were absolutely vital for bringing an end to the pandemic emergency, for preventing those severe illnesses that we saw too often around the world in 2020 and in 2021. And this was the first thing that we needed from the vaccine. We needed people to stop getting sick and dying from COVID. But a better vaccine could do much more. A better vaccine could stop COVID in its tracks. A better vaccine, maybe the next generation of COVID vaccines, could actually just stop us from getting infected in the first place. And if that vaccine stops us from getting infected, it stops us from transmitting the infection to other people, which means we can protect the elderly, young children, people with suppressed immune systems, who, despite getting vaccinated, remain vulnerable to a severe infection. But what would such a vaccine look like? How do we develop one for COVID? And out of all of the many brilliant ideas for a vaccine, some of which are being developed here in NTU, how do we decide which is that best one, the one that we should take forward into large clinical trials and spend hundreds of millions of dollars so that we have something that for the next pandemic is safe and effective? And this is where studies that intentionally expose volunteers to an infection come in. They're called controlled human infection studies or human challenge studies. They've been conducted safely and ethically around the world for many years, but they are new to Singapore. Challenge studies involve deliberately exposing volunteers to a virus or a bacteria or whatever it is that causes an infection. Sometimes that bacteria or virus has been weakened. Sometimes it's actually the same as what circulates naturally. And of course, the volunteers who put themselves forward for these studies are putting themselves at some degree of risk. And the studies are very carefully designed and reviewed by independent ethics committees to make sure that those risks are as minimal as possible. So, for example, we'll make sure that volunteers who join the study have no significant medical history or no ongoing medical conditions. Secondly, volunteers will undergo a comprehensive medical examination to make sure that they don't have any conditions they don't know about. And finally, we're very careful to counsel all of the volunteers to explain to them exactly what the rights and the responsibilities are for joining the studies, and also what the risks and the potential rewards are. And as a result of these, thousands of people have taken part in challenge studies over the past 40 years, and with remarkably few complications. So why is it that we do controlled human infection studies? And it's really about that keyword, controlled. When I put a virus in somebody's nose, I know exactly what I'm giving them, I know exactly how much of it I'm giving them, and perhaps most importantly, I know exactly when they're receiving it. And this enables then the research that happens afterwards to be incredibly precise. The difference between a traditional clinical trial and a human challenge or controlled human infection study is a bit like the difference between a surprise test being sprung on you by your tutors and a test where not only do you know when it's going to be and what you're going to be tested on, but you actually get to write the questions yourself as well. In the first exam, you're unprepared. You just need to do the best you can with what you've got. But in the second, you can be absolutely sure that you can make the absolute best of it. And this difference between a traditional trial and a controlled human infection trial, surprisingly perhaps, means that potentially it can even be safer as well. And this is because when we're conducting a traditional clinical trial, there is a lot that remains left up to chance. Let's take a clinical trial of a vaccine, for example. We want to test this experimental vaccine to see whether it's effective at protecting people against infection. But after we give them the vaccine, we actually don't know whether they're ever going to be exposed to that infection at all. And a difficulty on top of that is that even if they do get exposed, and let's say they do get infected, we don't know whether we're going to be able to detect the infection. And then even more than that, even if we do realize that they have this infection, we may not be able to detect it at the right time, and we may not be able to get the right samples in time as well. With a human challenge study, because we directly engineer that exposure to the virus, we can test the vaccine in a very precise and controlled way, and we can really work out quickly and in a smaller number of volunteers whether this vaccine looks effective, and so whether it's something that we should take forward into those big studies. Malaria, cholera, influenza, these are some of the infections where controlled human infection studies have been really important at bringing vaccines into people. And where are we going with this? Well, firstly, Singapore is, I think, an ideal place to conduct controlled human infection studies. We have world-class scientific infrastructure and people. We have ethical, legal, and regulatory systems which are internationally recognized. On the world stage, we can't always compete with size, but we can compete with impact, with technologically advanced studies that could change the world. Secondly, in a clinical trial being conducted next year, we will be beginning the next phase of our work. And this work will help to bring public trust and public understanding, we hope, in this process so that we are ready for the next pandemic. In this study, we'll be testing a next-generation COVID vaccine to see whether by vaccinating people in the nose, rather than through an injection, we can protect people from getting infected with COVID in the very first place. And if this works and we can block infection, then we can help people now against COVID. And we can then also apply this knowledge when a future outbreak or pandemic threatens, and we can hopefully stop it before it has even taken hold. So I'm standing here today talking to you about challenge studies, and I hope you're intrigued by what they can offer and maybe even a little bit excited by the opportunities that they can give as well. The most important person in these studies is the volunteer, because without the volunteer, none of this can happen. The people who choose to volunteer for our challenge studies come from a wide range of different backgrounds, and they choose to participate for a diverse range of reasons as well. For some people, it's about altruism or a sense of giving back. For others, it can be a chance to do something different, something meaningful. And for some people, the financial compensation is attractive. Whatever the reason, I hope that the next person who will be joining us on this study will be you. Thank you very much.